All right, so we're just going to do some story type problems for sine cos tan. And one of the challenges, it's just like the ones we've been doing, except now we have to like make the picture, all right, and label the sides and the angles and stuff. Sometimes they'll give you a picture, right? I'll do a couple like that, but on this first one, they don't give us a picture, so we have to draw it. So I'd actually pause the video here and see if you can draw a picture of what's being described here, and then on pause to see if it matches what I've got. Okay, so I'm going to draw a ladder. This is the best I can, and I'm going to label that 12 feet. It's leaning against a building, so we'll add in our building here. Looks something like that. All right, and then we want to know what is the distance from the base of the ladder to the base of the wall. Okay, so that would be sort of from this point right here to this point right here. Okay, so that's what we want to know. That's x. And we know that the where the ladder hits the building, it forms a 22-degree angle. Okay, so I'm going to label that right in my picture. Okay, now it's just like the other one. So you could pause here and see, is this a sine cos tan one, and then see if you can get the right setup. Okay, so this one would be, I believe, sine because we have the opposite labeled and the hypotenuse labeled. So we would just say sine 22 degrees is equal to the opposite x over hypotenuse 12. And then sine 22, right, we can just turn that into a ratio on our calculator. So sine 22, check the mode again, make sure you're in degree mode all the time. So we have 0.37. So I get 0.37 over 1 equals x over 12. And now I do my cross product. So 1 times x is just x. And then the other one is 0.37 times 12. So I'm just going to take this times 12. We should get something less than our hypotenuse. So we get about 4.5 approximately. All right, so that missing side there is 4.5. Okay, so this is another sample ACT question. And I would pause the video. You don't actually have to do any decimals here. You just kind of got to do the setup and then figure out which of these answers is right. So pause the video, give it a shot before watching the solution. Okay, so we want to do an expression for the distance in miles from the boat to the dock. So boat to the dock would be right there, and we're just going to do an expression. So if we were solving it, we would do, here's our reference angle, and our sides would be the opposite leg and the adjacent leg, right? So that would become tan. So we would say the tan ratio for a 52-degree angle has to equal our op to adjacent. So our op is x and our adjacent is 30. And so that would be sort of our setup. And you can see that doesn't match any of these, but we could solve this then for x. So without doing the decimals or anything, if we just multiply both sides by 30, that would wipe out the divide 30 here. And we get a little expression saying x is equal to 30 times tan 52 degrees. Okay, and so that would be an expression for x, and that's what we could type in our calculator to get the actual decimal value, but all they want is the expression here, so it ends up being that as our right answer. So it's kind of like what we've been doing, just kind of a slightly different style question. All right, last one. You got 12 students lined up to have their picture taken. They're 26 feet apart. The camera is 52 degrees if you go from here to here, right? Get all the students. And we want to know how far is the camera from the student. So again, I would pause the video and try to make much sense of this as you can before watching the solution. Okay, so basically what we want to find is right here, this distance from the camera to the students. Okay, so I'm going to call that x. All right, and then what we don't have a right triangle initially, right? There's nothing here that is a right, like the initial triangle is not a right triangle. But if we use half of it, right, this is a right angle here. So if we do 13 up here, half of the 26, and then x here, we can actually do sine, cos, or tan, right? And then the other piece is the angle is not 52, but half of that 26. So in this little half triangle, I'll try to highlight it here. We have x on this side, 26-degree angle, and 13 on that side. Right, so sorry that looks so poor, but this last side is that side that's out here. Okay, so again, is it sine, cos, tan? Here's our angle, and we have op and adjacent. So this would be a tan question. So we would say the tan ratio for a 26-degree angle, because remember, this is angle in the half triangle there, which is the right triangle, is op 13 over adjacent x, and then we just got to solve that. So tan 26. Okay, so we get about 0.49. So we get 0.49 to 1 equals 13 over x. And now I do my cross product, so I get 0.49 times x equals 1 times 13, which is 13. So now I just got to divide 13 by that 0.49 number. So I'm going to do 13 divide by my previous answer. So it's about 26.7, I guess, if we rounded it. Okay, so that is the distance from the camera to the students. Okay, so, and that will come up a lot. Like if you don't have a right triangle, like if they give you a non-right triangle, oftentimes you can draw on the height and then use that in your question. So like lots of times they'll have that where you've got to draw in that height of the triangle and then it forms a right angle and then you can use sine, cos, tan. Right, that's something I've seen on quite a few both MCA and ACT questions. So, here's another example. This is a equilateral triangle. There's no right angle initially, but if I draw on the height, now I've got a right angle, and now I can use sine, cos, tan. So that's just something to watch for on these questions. All right, thank you for watching.